Hello again everyone, welcome back to ptet.chemistry channel. My name is Dr. Ant. In this tutorial video, we'll go through this year 10 end of year assessments. These are basically with my students who have basically done all the topics in the pure science, triple science curriculum for the 3-year program. So in the 2 years, we have completed all the topics, which included everything except for organic chemistry as well as environmental chemistry. So in this particular paper, in this tutorial, you will not see any questions on environmental chemistry, neither will you see any questions on organic chemistry. Well, regardless, the contents within should be entirely suitable for any 14 to 16 years old students doing the GCSE or the IGCSE extended or core curriculum. In this first question, so the scientists needed to add approximately 100 cm cube of water, and this is approximately, so not very accurate. That's the first thing we can comment. And the second thing is this scientist wanted to do it as quickly as possible. So the use of burette and pipette, these are very accurate. So accurate, but takes time. Okay, and you can see that because you wanted quite a large amount, that these are not practicals to be used, twice for 50 cm cube, because 50 times 2 is 100 cm cube, and pipette 4 times 25 give you 100 cm cube. Very accurately, but take a lot of time. Gas syringe, this one is for gases. We have the measurement for water, which is a liquid. In other case, you have solutions. Therefore, we use measuring cylinder rather than any of these apparatus as shown there. Question number 2, we have 4 mixtures, each one containing 2 substances. Now you need to separate the 2 substances and you want to collect both substances. So there's the key criteria there. You want to collect both substances after you separate them. Copper 2 sulfate and water. So copper 2 sulfate and water, usually we use crystallization. But even after crystallization, you will still get saturated solution, which is not pure water. So one of the other way you could do this is you would do distillation, where the copper 2 sulfate would just remain inside the round bottom flask and the water will be collected as the distillate. Chromatography is definitely a big no-no. That's why I say usually here, depending on what exactly do you want. Do you just want to separate the copper 2 sulfate crystals from the solution, which will still contain a little bit of the copper 2 sulfate dissolve, of course. Methanol and ethanol, this one have different boiling point. We don't use evaporation. We can use distillation instead. In fact, simple distillation or maybe even fractional distillation, because these two are alcohols. Unlike ethanol and water, you can use simple distillation. I think methanol and ethanol, the boiling point is a little bit similar, so you might have to do fractional distillation. The difference being that this one requires a much taller fractionating column and a slightly different setup than a simple distillation. Oxygen and nitrogen, the A, definitely we can get by fractional distillation, and that's how we get our oxygen and nitrogen, the A, to be honest, fractional distillation of liquid A. Sand and barium sulfate, this is solubility rules. Barium sulfate, test for sulfate, white precipitate, insoluble in water. Sand is also insoluble in water, so both of them are insoluble. You can't separate them by filtration. So C is the only best answer there. Question number 3, this is about qualitative analysis. The table of results will never ever be given in a theory paper. So we have this aqueous sodium hydroxide as well as aqueous ammonia. These are tests for cations. If we look through the options A to D, we can see that this is about anions, whereas the test was all on cations. So test for chloride involve, adding nitric acid. After you add the nitric acid, then you add the silver nitrate solution, or you can say silver nitrate, aqueous silver nitrate is the same thing. And then you will get a white precipitate as a result of silver chloride being formed. But none of these are basically tests for chloride, so we're not testing for chloride. We get a white precipitate with a little bit of NaOH. it dissolves in excess of NaOH, you get a colorless solution. They don't mention it, but between Al3 plus and Zn2 plus, you do get a colorless solution when it dissolves in excess NaOH. And we know both of these hydroxide, both the aluminium hydroxide, Al3 plus OH minus 3 times, and also the zinc hydroxide, Zn2 plus and OH minus twice, they are soluble in excess NaOH aqueous, and that's why it's important when we think about the table, we always specify what excess reagent did we use, so that we always try and remember it. So the only useful reagents for differentiating between these two is really using an excess of ammonia, and this precipitate dissolve, so it has got to be Zn2 plus and not Al3 plus. So C in excess aqueous ammonia. What exactly happened there? Question number 4, what describe the changes in particles when a substance freezes? So freezing is to do with liquid going to solid. If you have a description of a diagram of liquid, so it's a bit less ordered than solid, whereas in solid you have the particles just tightly packed and they can only vibrate in a fixed position, whereas liquid particles can slide past each other. So definitely going from liquid to solid, they're becoming more ordered. So C and D are out. In terms of the energy change, we need to think about our cooling curve. So back in states of matter, you will have done something called cooling curve, where it's kind of like the opposite of heating curve. So as we cool down, then the particles will definitely lose energy, because that energy is going to be released to the surroundings, as that is what we call exothermic change. So freezing is exothermic, melting is endothermic, because when you melt something, melting point, melting process, you need to absorb energy in order to break whatever bond that you need to break, depending on the structure and also bonding. So the particle will lose energy when you freeze. Particle will absorb energy in order to break some sort of bonds, depending on structure, when you melt or when you boil. Question number 5, ethylamine. So this is not the usual ammonia. This is C2H5NH2. So the MR of C2H5NH2, because we need to compare the MR value. So 12 times 2 plus 7 times 1, because we have 5 hydrogen plus 2 hydrogen is 7 hydrogen. And then we have 1 nitrogen, so 14 times 1. Summing up the relative atomic mass straight from the periodic table, that's how you do MR. MR of HCl, hydrochloric acid, hydrogen chloride gas, 1 plus 35.5 give me 36.5. So this one is lighter. So lighter mass, therefore faster to diffuse. If you diffuse faster, you will travel longer distance. B there, it's your midpoint, and you will meet at the midpoint if you have the exact same mass. With ammonia, it's lighter than HCl, but with this ethylamine, it's heavier than HCl. So HCl will travel closer to the ethylamine, leaving A as the only possible answer there. Question 6, with this kind of question, this is about counting the number of protons, electrons, and neutrons. So we need to always try and visualize, or try and calculate out what are the number of protons. So at the number at the bottom there, so this is what you call the proton or the atomic number, whereas this number on top here, that is what you call the nucleon number, which is to do with the number of protons plus the number of neutrons, which means when you take the difference between the top and the bottom, you will get the number of neutrons, as this minus this will just leave you with the number of neutrons. So the number of protons is based on the atomic number, the identity of the element. The number of electrons depend on if you are atoms or if you are ions. This is a 2 plus, whereas the cobalt is a 3 plus. A positively charged ion means your atom has lost electrons. So your atom will have 26 electrons, you have lost 2, now you're left with 24 electrons. So here will be 27 minus 3. Your atom has lost 3 electrons, that's why you have become a plus 3. This is going to give you 24 electrons, so 7 number of electrons there. How about neutrons? Well, you can get 54 minus 26, and that gives you 28. And what else? 59 minus 27. This gives you 32. So which term about this particle is correct? Same number of protons, I can tell you they are not, because Fe versus cobalt, they are what you call different elements. Proton number or the atomic number is going to be the identity of the element. So whether you're element or ions, definitely different element, different symbol, different number of protons, be it a C and D are out. Same number of neutrons, they are not, but in fact, if you're going through A, B, C, and D one by one, you will have gotten same number of electrons based on the different charges there. So A must be the correct answer there. Question 7, you have two isotopes of chlorine. These are specific case study, even from year 9 chemistry content. Chlorine 35 and chlorine 37 is present in 75%, 25%. We call it 3:1 isotopic abundance ratio. Relative atomic mass from your year 9, the percentage number times the mass number, the percentage number times the mass number. It doesn't matter which way around it is, as long as you have percentage times the mass number. Sum up the whole thing and then divided by whatever you have there. So I've used percentage, so I'm dividing by the total percentage. If I have 3 times 35, 37 times 1, that will be dividing by 3 plus 1, which is 4. And you will get 3550 over 100. And this is what you defined as relative atomic mass. It is not mass number. It's clearly labeled as relative atomic mass in the periodic table. It's also defined in the syllabus as the average mass of all the isotopes of the element, and this is relative to a standard. It's called 1/12, 1/12 of the mass of one atom of carbon-12 as stated in the atomic structure topic, as well as the definition for relative atomic mass. This question is about you having 3 chlorine, and the C2H3 is a fixed mass because we're just looking at carbon-12 and hydrogen. 1, so that is your fixed mass. So really this is mathematics question. What are the possible relative molecular masses combination? I could get chlorine 35, chlorine 35, chlorine 35. So that's going to give me 35 plus 35 plus 35. That will be the lowest mass combination. Of course, you have to add in the carbon and hydrogen as well, but we know those are fixed values depending on just the chlorines, which are very different value here. So the next one will be chlorine 35, 2 of them, and I'm slowly increasing the number of chlorine 37. So here will be 35 plus 35 plus 37, and this will give me 107. So having done that, you could imagine that the next one we're going to do will be 35 chlorine, 37 chlorine, 37 chlorine, and this will give us 109 there. And what's the next one I could do? Trying to find some more space so that I'm not restricted by this space here. So I've got 3 possible mass combination already. Now I guess the last one will be 37 chlorine, 37 chlorine, 37 chlorine. That give me 111. Of course, like I said, you also have to add it with the 12 times 2 plus 3 times 1. But these are the 4 different mass combinations. There are no any other combinations because you could have 35, 37, 35, but there will still be 235 and 137. This is 135, 237. This is none of the 35 and all of that 37. The mass gradually increases. This is called being systematic, and you will see that there are 4 possible mass combinations altogether there. Question number 8, we are talking about room temperature and pressure. Which one is correct? This is what you call ethanol. So even though you haven't done organic chemistry, this is also in year 9, dot and cross of methanol. So you know about carbon forming 4 bonds, you know about hydrogen forming single covalent bond, you know about oxygen forming 2 covalent bond like that. Therefore, we can establish that this one, like methanol, has a simple covalent structure. That means it exists as individual molecule, and therefore it has low melting point, low boiling point, as it has weak intermolecular forces of attraction between this molecule and its next molecule, and so on and so forth. Y has to be the structure of diamond. This is what you call the giant covalent structure. and it has many strong covalent bonds to be broken. Do not get confused between structure and also bonding. And what do we know? X is going to be your ionic compound. This is Cl minus anion. This is Li plus cation. These are your alternating anion, cation, up, down, left, right, in front, and at the back as well. So this is your giant ionic structure. You have strong ionic bonds between oppositely charged ions. Of course, there are no free electrons because all the electrons get transferred from the metal to the non-metal. They are inside your shell. On the other hand, this is actually alloy for W. Alloy is what you call a mixture of metals. So they are not showing you the electrons on the outside, but actually you have C of delocalized. Delocalized because these electrons have been lost from the outer shell. And what you have now are basically cations, but these are different cations, so they have different sizes and they are no longer malleable, and alloy is not as malleable as a fixed metal. But being a mixture of metals, each metal still has its own giant metallic structure. So, you know, you have electrons still lying around, and therefore you have free electrons to conduct electricity. W, yes. X cannot, because this is a solid at room temperature and pressure. So no free ions, as you only vibrate above fixed position. So X there is wrong, so A is wrong. W and Y are elements, not W. W is a mixture of metals, so it's what you call alloy. And B is wrong. X and Z dissolve in water. Well, X dissolve in water based on solubility rules of chloride. You will know that lithium chloride is soluble because only silver chloride and lead 2 chloride are insoluble. Solubility rules, year 9, experimental techniques, as well as in year 10, you know, in the acid, bases, and salt stuff, under solubility rules and salt preparation. So this one is solubility rules of your chloride. And then Z is ethanol. We use ethanol dissolved in water to make us our solvents for hand sanitizers, for perfumes, etc., etc. So C is correct there. Y and Z, Y has very high melting point because many strong covalent bonds to be broken due to the giant covalent structure if you want to melt giant covalent structure. Question 9, you have a piece of magnesium. Magnesium is a fairly reactive metal. If you have done year 10 reactivity series, you will have known about the polycarmazole. But metal plus acid is also a year 9 concept. So you have Mg plus HCl, and you will get magnesium chloride. The metal salt, the metal is Mg, forming Mg2 plus by losing 2 outer shell electrons. The chlorine will have formed the Cl minus, against 1 electrons from the atoms to form the ions. So this is valency, which is the combining power of the ions based on the charges. And then we crisscross, and this is lowest common multiple. It means how many of the Mg2 plus and how many of the Cl minus combined together, such that the plus 2 minus 1 total up to give you MgCl2 without any charge whatsoever. Hydrogen as a diatomic molecules to fill up the outer shell for each of these hydrogens. Balancing your equation is a common year 9 concept. We have a resulting solution which is evaporated, giving us the residue of MgCl2. Well, what do we know about the MgCl2? Well, we just said it's Mg2 plus and Cl minus, a covalent solid. Nonsense, should be ionic solid. Each chlorine atom gain 1 electrons. Chlorine started out with 2H7. Of course, when you form chloride, you just gain 1 outer shell electrons. So that one will be going from 7 to become 8 is correct because it's each. And I have 2 because the magnesium give away 2 electrons, 1 to each of the chlorine atom. That's why I need 2 chlorine atom forming 2 chloride ions, which is also why the next one is actually wrong. Each magnesium loses 2 electrons because from magnesium to A2, you need to lose and give away 2 of your electrons. This one give away to 2 of the chlorine, which can only accept 1 at a time. And now you have Mg2 plus, which have a fully filled outer shell. And D is wrong because of molecules. You don't get the molecules, you get a compound, ionic compound, giant ionic structure, alternating cations and anions there. Question number 10, this is carbon dioxide. These are from year 9. Year 9 under dot and cross. Carbon with 2 4 electronic configuration. Oxygen with 2 6 electronic configuration. We don't use the 2 because the inner shell. So we never use inner shell electrons in order to form covalent bonds or any sort of bond. Okay, so we just don't involve them because we only show the outer shell electrons involved in bonding. Having said that, the carbon will share 4 electrons, the oxygen will share 2 electrons. So if we think about carbon, they will share 2 electrons with each oxygen, but you have another 2 electrons on the carbon, you need another oxygen. Oxygen shares 2 out of 6, that means you are left with 4 more on the oxygen. You are left with 4 more on the oxygen. Here you have 6 more on the oxygen, here you have 6 more on the oxygen, so B and D are out. Here you have 6 more on the oxygen, A is out, only C is correct. So you can see a double covalent bond, 4 electrons being shared, another double covalent bond, another 4 electrons being shared, leaving 4 electrons left on the oxygen after you share 2 out of 6 for each of the oxygen there. Question 11, this is about structure and properties of metals. Metals are malleable, so you have layers of cations, and these cations are of the same sizes. And what do we say about them? They can slide over each other easily, and that is what makes them, being able to change its shape easily when you apply a force upon it. And when we draw the giant metallic structure of metals, we show that we have cations, and we also show that we have C of delocalized valence electrons. Valence meaning you have lost from the outer shell. Delocalized, they are no longer in the shells. You have free electrons, mobile electrons, therefore they can conduct electricity. And they are malleable, they have high melting point except for group 1, but in general we just say that in general metals have high melting point. So what can we say? Both statements are correct, but statement 2 does not explain statement 1 because this explains conductivity. These are based on the layers of cations. This is based on the giant metallic structure, strong metallic bond between the positively charged ions and the C of delocalized valence electrons. The low melting point of group 1 is not like extremely low, like making it a gas, but it's just a bit lower compared to other metals, so it's still relatively high compared to non-metals. But between metals and metals, group 1 have the lowest melting point for that particular peculiarity. Okay, so we still say both statements are correct, but the second one does not explain statement 1 because they are not related whatsoever. Question 12, how many different elements are present in ammonium nitrate? Ammonium ion, test for ammonium ion, NH4+. Nitrate ion, NO3-. So altogether, the +1 cancel the -1. Your formula is NH4NO3. What element do you have? Nitrogen, hydrogen, oxygen. Of course, you are present as an element N2, you are present as H2, you are present as O2. These are elements, but once they combine together, they give you the compound itself, no longer as the diatomic element. So you have 3 different elements that are represented in ammonium nitrate. Question 13, there's a shortcut and there is a long way, but ionic equation is a year 9 concept under balancing equations, balance atom and balance charges. Calcium hydroxide dissolved in water. This is the presence of OH-. Alkali, base. Alkali is a soluble base, so the pH is greater than 7. Neutralization, according to the question, dilute nitric acid. Acid dissolved in water to give you H+ and NO3-. And then these aqueous ions will give you calcium 2+ and OH-. Of course, you have 2 of them in order to balance out the +2. Calcium hydroxide is actually CaOH twice. Well, I hope you are able to, get to the formulation 2 and 1. 1 and 2 is a common year 9 confusion. where you can see there are 2 oxygens, and therefore we write CaOH bracket twice, the 2 representing 2 of these whole units there. But we know about ionic equations, it's as simple as possible. So we also see calcium nitrate there. This is wrong formula. Should be 1 of the calcium 2 plus and 2 of the nitrate. However, all nitrates are soluble. All nitrate salts are soluble in water. This is solubility rules. So they are aqueous. So therefore, they are what we call spectator ions in year 9 chemistry. Under ionic equations, cancel out the spectator ions such that you get the base, which is OH minus, the acid, which is H plus, and this is just water, and you are forming a soluble salt in this case, and the soluble salt spectator ions, they get cancelled out. Therefore, this is the one and only ionic equation for neutralization reaction there. Question 14. Relative molecular mass. This is basically the sum up all the relative atomic mass. If I look at the molecular formula first, so the MR of CH2O, that is 12 plus 2 times 1 plus 16. So 12 plus 2 times 1 plus 16, they give me 30. These two are the same, so the MR of C2H4O2, so 12 times 2 plus 4 times 1 plus 16 times 2. And what does that give me? 24 plus 4 plus 16 times 2. That gives me 60. So it seems like that is multiple of 2. And this one is a bit different. It is H6. So it looks like I am just adding 2 more hydrogens. You can work it out using a calculator. But I can see from here to here, it's just adding 2 more hydrogen. It's just 62. Now I want it to be 60, so not this, so A and D are out. Empirical formula versus molecular formula, year 9 concept. Molecular formula, the actual number of atoms in one single molecule, so simple covalent structure. Empirical formula, simplest whole number ratio, of your atoms or your ions, which are not applicable in these covalent molecules. And we have simplest ratio 2 for 2. So carbon is to hydrogen is to oxygen. You can simplify by dividing by 2 throughout, and you will get C1H2O. So there must be this empirical formula without you even doing the calculations. This is multiple choice questions. You need to work very fast. Question 15, this seems to be a calculation question. Produce 27 tons of aluminium from the aluminium oxide. So you can write the equation for it. This is basically the electrolysis of Al2O3. Aluminium is not diatomic. Aluminium is a metal. It's not a molecule. And then O2 gas is diatomic as a non-metal. We balance our equation, 2 aluminium in front and 3/2 oxygen. If you want, you can multiply the whole thing by 2. I'm just going to keep it simple. It's already balanced with the correct formula. Now I do need the MR. So the MR of Al2O3, we think about MR being for 1 unit. So the MR of Al2O3 is going to be equal to 27 times 2 plus 16 times 3, that is 102. And then the MR of aluminium, this is for 1, basically it's the AR actually. Even though we have 2 aluminium there, but MR or AR is for 1, is gram per mole, that's 27. So what's the next thing I can do? I have my balance equation. The next thing is set up my all-in-one ratio. I want the Al2O3 information, so I put the Al2O3 on top. And from the balance equation, 1 Al2O3, so 1 mole of Al2O3 produces 2 mole of aluminium. And then on the top there, I have my mass of Al2O3 divided by 102, that is the actual mole of Al2O3. And I have 27 tons of aluminium divided by 27. This is gram over gram per mole, mass of MR, mass of MR. This is in tons, so this is in tons as well. We already set up the mole ratio from the balance equation. So you can see that these are set up very clearly, the all-in-one method, which we have done since year 9 for all our mole calculation chemistry. And so there's a half times 27 over 27 times 102, and I will get 51 tons. Oops. So there is 51 tons of Al2O3 there. B there. Question 16, lead 2 bromide is electrolyzed using inert electrode. This is molten lead 2 bromide. So I have Pb2 plus and I have Br minus. Pb2 plus is cation. So cation will go to the cathode. Cation are positively charged ions. So this makes cathode negatively charged electrodes. What else do I know? I also know that reduction happened at cathode, courtesy of red cat. Reduction happened at cathode. I also know about oil rig. Reduction is gain of electrons. So Pb2 plus cations, positively charged go to cathode, which is negatively charged electron. Reduction happened at cathode, red cat. Reduction is gaining electrons. So gaining electron plus the electrons onto the Pb2 plus, forming Pb. Whatever equation you write must be balanced in terms of atom. 1 Pb, no charge for the element, plus 2, you need 2 electrons to gain 2 electrons in order to have no charge there. So Br minus then going to Br2. This one is at the anode because anion go to the anode. Anion go to the anode because the anode is positively charged since the anion is negatively charged. We know about red cat, so that means oxidation happened at the anode. We know about oil rig, so oxidation is loss of electrons. When we lose electrons, we will have plus electron on the right hand side. Br exists as Br2, diatomic molecules, just like all the other halogens. Balancing atoms, so 2 Br there, 2 Br there. Minus 1 times 2 is minus 2 on the left. No charge for the molecule. I need 2 electrons on the right. So which statement is correct then? A brown gas is seen at the positive electrodes. This is the positive electrode. Could you get a brown gas? Maybe, because this is molten, very high temperature. Br2, simple covalent molecule. So Br2, low melting point, low boiling point. Potentially, you could get a brown gas. Maybe Br2 gas. At the positive electrode is anode because anode attracts anions, which is going to be the Br minus, negatively charged ions. I think A is correct, but let's just go through the other option just to convince ourselves. Electrons pass through the solution. Okay, maybe A is not correct because by right it should be a liquid first. Let's see, by right, I think A might not be correct. Let's see, B, electron pass through the solution. I think what is wrong with this is that you don't really get a solution. There is no water. I think this is wrong because no water here, only molten. And then ions pass through the circuit. Not ions, but electron pass through the circuit. And the lead 2 ions are oxidized. That is clearly wrong. That is reduced. So I think we are left with A as the only possible answer again. Question 17, we have compound X, which is sodium iodide. So we know that this is a compound between a group 1 metal and a group 7 non-metal, such that you get these alternating cations and anions in a giant ionic structure. Giant ionic lattice structure. So alternating cations and also anions, which of course when we draw the dot and cross, it is not as clearly apparent, but we know about the strong ionic bonds between the positive and the negative ions. And as such, in the solid state, the ions are not free to move. The ions cannot move freely. There are no free ions, cannot freely move, and therefore cannot conduct electricity. This is metanoid, even though you have not done organic chemistry at this stage, but you should be able to relate to your year 9 dot and cross diagram, where we can also draw display formula, carbon forming 1, 2, 3, and 4 covalent bonds, just like carbon forming 4 covalent bonds. oxygen in group 6. So group 6 oxygen to 6 will share 2 electrons, so they form 2 covalent bonds there for this oxygen. It could also form 2 single covalent bonds like that, and of course hydrogens just form a single covalent bond. So this is a simple covalent molecule. So having said that, simple covalent molecules, simple covalent structure. Therefore, what about its properties? We know that it has low melting and boiling point. This is as stated in the syllabus, but also cannot conduct electricity at all because, no free electrons. It cannot be no free ions because these are not ionic compounds to begin with. At room temperature and pressure, which one is going to be a solid? It's going to be the ionic compound that is a solid, as this thing will have low melting and boiling point. Could be a liquid, could be a gas, but if you do organic chemistry later on, you will know that esters are mostly liquid. In aqueous solution, meaning you dissolve in water, these ions become free to move when you dissolve it in water. But this molecule doesn't give you ions still, as it is not acidic, and therefore what you have is only the ionic compound dissociate to give you free ions, so only X will conduct there. Question 18, for the forward reaction of a reversible reaction. Ooh, this is a bit tricky. So the enthalpy change is exothermic. So exothermic reaction releases heat energy to the surroundings. We are dealing with enthalpy change diagram. So we have energy against the progress of reaction or the extent of reaction, such that when we go from left to right, we would have gone from reactant going to products. So if this is your reactant and this is your product, we know from reactant to product, it's going to be exothermic because there's forward reaction. So this is delta H forward. It is coming down. It is exothermic, minus 50 degrees kilojoule per mole. And then the activation energy, which is from the reactant to the top of the peak. This is activation energy, which is plus 60 kilojoule per mole, whereas the enthalpy change was minus 50 kilojoule per mole. Now, what do the question want? What is the activation energy of the reverse reaction? Reverse reaction means from product to reactant, so going the other way around. And then activation energy means from the starting point to the top of the peak. So what do we have here? This is going to be your starting point for the backward reaction from the product to the reactant, and it goes all the way to the very top of the peak. So what is going to be the value? The value from here to here is plus 50, and then you plus another 60. So this is going to be plus 50 plus 60 is plus 110 kilojoule per mole. Draw the diagram and see it for yourself, and don't get tricked by this reverse reaction and what is meant by activation energy. Minimum energy that the reacting particles, in this case the product going to the reactants, would need to overcome before you can react. Before you go to the other side, you need to overcome this plus 50 and then plus another 60 there. Question 19, we have a titration experiment. Which row about the reactions in the conical flask is correct? So this is a titration experiment between an acid, which contribute the H+, and an alkali, which is basically a soluble base. A base is a substance that dissociates in water to give you OH-. We know about the classic neutralization ionic equation forming as water. This is a classic ionic equation for neutralization reaction. So what happened there is, well, we are not breaking any bond, but we have OH- like this. But now what do we have? We have formed a new covalent bond. So this is the new bond being formed, but you are not breaking anything at all, yet you are forming new bond. Neutralization is always going to be exothermic based on the ionic equation. You are not breaking any bond, you're just forming a new OH covalent bond as you form the water. When the H+ and OH- come together, exothermic reactions, delta H is negative there. Question 20, sulfur dioxide reacts with oxygen. This is the stage 2 of the contact process. A very, very important process, all of which involve 4 stages in order to make your sulfuric acid. Very slow if no catalyst is present. We know our catalyst is V2O5 as a solid, transition metal oxide, giant ionic structure, metal, non-metal, giant ionic structure, ionic compound. This is called vanadium 5 oxide. As is typical for any transition metal compound, must include the transition metal oxidation number. This is vanadium 5 plus, and if you think about working backward and exchanging the valency of 2 due to O2 minus, valency of 5 due to vanadium 5 plus. Which statement explains this? So it's saying that this reaction is very slow. Very slow is due to very high activation energy, and that means only a small proportion have enough energy to react, which is why when you have an alternative reaction pathway, which is the catalyzed pathway, you have an optional pathway. What is so special about this pathway? There is a new lower activation energy, and that is why the overall reaction can take place a lot faster due to due to new lower activation energy. There is more effective collision. Okay, so this is with a new lower activation energy there. So B is definitely going to be the most sensible answer, because A is just factual. It's not enough oxygen, so just use pure oxygen instead of using the A, which contain 21% oxygen. So we will use pure oxygen instead of using the A if we want to. Reaction is exothermic. Equilibrium shift to the left. Catalyst is to do with rate of reaction. It's got nothing to do with equilibrium position. So yes, the forward reaction releases heat energy to the surrounding. So yes, at higher temperature, the forward reaction will want to release lesser heat because you want to oppose the change. Okay, so you want to make the surrounding a little bit cooler, so you will release less heat. Yes, it will shift to the left. This is factually correct, but that is to do with equilibrium position. It explains the equilibrium position or the equilibrium yield, but it does not explain the rate of reaction, which is to do with high activation energy there. Question 21, these are flow chart. This is about preparation of ammonium. Ammonium is NH4 plus, and then you have sulfate. Sulfate ion is SO42 minus. Both of these ions are in the qualitative analysis test for ions. Both of these ions are also in year 9 table of ions, which everyone is supposed to have mastered. Ammonium ion 1 and 2, based on the valency of these two ions respectively. And then the objective in ionic compound formulation is to do lowest common multiple. Primary school mathematics, the objective is get the formula of the salt to cancel out the charges. This is the reaction between ammonia and also sulfuric acid. So when you have ammonia reacting with sulfuric acid, you will not get any water forming, because you will just be able to balance the formula with the formation of ammonium sulfate, 2 of that ammonium, 1 of that sulfate, plus 2 due to the plus 1 cancel out minus 2. Balancing our equation, one of these get the H plus, the other one get the other H plus. Now there is no other product. In other neutralizations, you would produce water, but when you use ammonia as a base, you will not get water. Otherwise, your equation will not be balanced and you end up with some random stuff. Haber process, this will make ammonia. Contact process, this will make your H2SO4. So of course, ammonium sulfate is the fertilizers, very important in agriculture industry to promote or to encourage the growth of crops. So what is our element number 1? Element number 1 and element number 3 must be nitrogen and hydrogen. So nitrogen and hydrogen. And then we have element number 2 and 4. So these are contact process. So it's not oxygen and oxygen. So oxygen and oxygen are wrong already, if you follow these two. So must be oxygen and sulfur in order to give you the sulfur dioxide, not the nitrogen and sulfur, not the nitrogen and hydrogen there, as there is contact process. So really we're looking at option A as the only possible answer there. Question 22, which statement is correct? So this is about enzyme. We know that enzyme is basically biological system. So it is a biological catalyst. It's not a compound of transition metal. It is a natural catalyst, and it will make the reaction faster. It speed up biological activity, biological reactions, biological activity. So that means, how does it speed up? How does it act as a biological catalyst? Basically, well, it will provide alternative reaction pathway, and that will have a lower activation energy, such that you get greater number of effective collisions. Therefore, your rate of reaction is going to be faster there. Question 23, this is an equilibrium, so it's a reversible reaction, but it is also in equilibrium. So we have difference in color. This is dark brown, this is colorless. Depending on whether you're going to favor to the right, it's going to become paler and becoming more like colorless. If you favor to the left, you're going to get more and more brown coloration. More oxygen is forced into the flask. So what is our change? Our change is increase the concentration of oxygen. So there is more oxygen in the flask. So what is our counter change? Counter change meaning your equilibrium will try to oppose the change. How would you oppose the change? You want to decrease the concentration of O2. Now where is O2? O2 is here. So if you want to decrease, you want to make this amount lower, what would this equilibrium try to do? React more O2. So therefore, react more O2, but O2 is on the right side of the equation. If you react more of the O2, that means the equilibrium will shift to the left, and therefore it will react more of the oxygen. As you shift to the left, you favor backward reaction. If you favor backward reaction, we are going to get more of these dark brown coloration because we produce more of the NO2. So we get more NO2, the yield of NO2 increases, and the color as shown above is more dark brown coloration there. So become a darker brown. No change is definitely wrong. Turning colorless will go the opposite way. Paler brown will go the opposite way as well. Since you're going backward, we get more and more darker brown there. Question 24, corn hydrochloric acid is oxidized by manganese 4 oxide. So what are the two products of this reaction? So this is the oxidizing agent. As stated in the syllabus, oxidizing agent oxidizes the other substance. So this is Cl minus. So Cl minus would get oxidized, and this is chlorine minus 1. Oxidation involves losing electrons, so I will have losing electrons. Cl minus loses electron. That's the meaning. Cl minus loses electron. What do you produce? You must produce CO2. They are not asking us to balance the half equation, but there are two chlorine. There are two chlorine. Minus 1 times 2 is minus 2. No charge. So that one must be 2 electrons there. And we are looking at CO2. Cannot be Cl minus, then there will be no redox. Cannot be Cl minus, then there will be no redox as well, because it's being oxidized. So something must happen there. Okay, so this oxidizes that, and we know it's CO2 and CO2. So that is one part of the story solved. But then what is the other oxidizing agent do? So oxidizing agent oxidizes the other substance. It oxidizes others. But the definition is incomplete. What happened to itself? Itself gets reduced. So we started with manganese IV, that is manganese 4 plus. So if we started with manganese plus 4, that is manganese 4 plus in manganese 4 chloroxide, that means itself get reduced. Reduce would mean decrease in oxidation number. So oxidation number decreases. So from plus 4 cannot go to plus 6. That is impossible. So it can only go down. That means B must be the only answer based on the statement given in the question. Question 25. Which statement about acid and bases is correct? All strong acids react with carbonate all weak acids do not. That is wrong, because all acids contain H+, and then when you have H+, they can react with carbonate. As you will know, the test for carbonate, you react with all acid in order to give you the effervescence, and you test the gas for carbon dioxide by bubbling the gas into lime water, and it will turn milky. The oxides of group 1 metals are amphoteric. That is nonsense. It's actually basic oxide. Amphoteric oxide includes zinc oxide, ZnO, as well as Al2O3, aluminium oxide. Now the pH of ethanoic acid, so this is a weak acid. It is higher than the pH of sulfuric acid. That is kind of true. This is around pH 5, pH 6. This is around pH 1, pH 2. But hang on, let me see. The pH of 1.0, so it has the same concentration, but we know about partial dissociation. So it doesn't completely dissociate. It only partially, oops, I don't mean that. It only partially dissociates into H+. So despite you having, the same concentration, not all of it dissociate. Therefore, it's much less acidic, weak acid, much higher pH then. Whereas this is a strong acid and strong acid, and therefore both of them are going to dissociate similarly. So the pH might be a bit lower, but we don't know that for sure. We know that the pH is going to be roughly the same. I think shouldn't be lower, should be about the same. So that is why that is incorrect. Maybe it could be the same. No, it should be about the same, because we have HNO3 going to H+ and NO3 minus. We have HCl going to H+ and Cl minus. pH is to do with your amount of H+. It's the same in both cases, since you started with the same concentration and both are strong acid there. Question 26, we have 4 redox reaction. What is being oxidized? And the evidence that this is oxidation. We know that oxidation involves gain of oxygen. This is probably the most useless definition unless you have the correct context or the correct case study. We talk about loss of electrons. Oxidation is loss of electrons. We talk about oxidation number increases. Now in this particular reaction, this is actually going to use the gain and the loss of oxygen atoms. If you see the copper, the CuO loses oxygen, so this is going to be reduction, not oxidation, so that is already wrong. Now the sodium and the chlorine, there is no oxygen there, so let's look at oxidation number, Na0, Na+1, and the reason to look at that is because this is Na+, Cl-, whereas this is sodium as an element. So oxidation number of element is 0. Oxidation number of of the atom in the element is 0. Of the atom in the ionic compound in the ions follows the charge of the ion. 0 to +1, increase in oxidation number. Sodium has lost an electron. That is correct, because you can also be looking at Na element going to Na+ by losing electrons. Oxidation is loss of electrons. You can also look at that way. In terms of the nitrogen in the next question, this is nitrogen 0 as an element. This is hydrogen +1 in a compound. If we look at oxidation number in NH3, the overall compound has 0 oxidation number. Nitrogen +3 times +1, each nitrogen is -3. We write shorthand so that we know exactly what atom we're looking at. Decrease from 0 to -3. This is getting reduced, not oxidized. And next up, this thing is zinc 2+ in the nitrate salt going to zinc as a metal. So what must happen is the zinc 2+ must have gained 2 electrons. Reduction is gain of electrons. You want something which is getting oxidized, so that is definitely wrong there. Only B is the correct answer there. Question 27, this is to do with solubility rules. Cambridge will not ask you, what is rule number 1, what is rule number 2, etc., etc. But there are a few things like all Na+, K+, and NH4+ salts are soluble. So you're looking for something which will precipitate out or insoluble in water. What could be present cannot be sodium. Sodium cannot be, because all sodium, potassium, and ammonium salts, if they contain Na plus, cannot be. Okay, so this is wrong. Now, how about the anions? We know that all nitrate salts are soluble. So as long as you contain nitrate anion, you're going to be soluble. So this one is wrong. This one is also wrong. So A and B are out due to the sodium ions, and then between C and D, D is out due to the nitrate ions being soluble, cannot be nitrate. Now you're left with calcium carbonate. Ca2 plus, you tested that in qualitative analysis. CO3 minus, you tested in qualitative analysis. We could exchange the valency based on the charges, but as for how many of these ions we have, that is not entirely correct, because we know we can just simplify it to the simplest whole number ratio, because the plus 2 cancel minus 2. Calcium carbonate is insoluble in water. This is a chalky milky precipitate that you get when you react calcium hydroxide, which is basically lime water, saturated solution of lime water, plus carbon dioxide. You precipitate out calcium carbonate, which is the white or the chalky or the milky precipitate, and you get H2O. That's the test for carbon dioxide gas. Bubble the gas into lime water. Lime water goes milky or chalky, because in chalk you also have, calcium carbonate, which is component of chalk to begin with. Now, question 28, we have a pure sample of lead sulfate. This is about separation techniques, but to do this, we really need to know solubility rules of sulfate. So we say that there is that thing in the solubility rules. All sulfates are soluble, except for a few. We know that barium sulfate, due to the test for sulfate with barium nitrate, after we have added the nitric acid, then we add in aqueous solution of barium nitrate or barium chloride, and we get barium sulfate, white precipitate. Calcium sulfate is also insoluble. Last but not least, lead 2 sulfate is also insoluble. So this thing is insoluble. If it is insoluble, how in the world do you prepare it? Well, you need to separate it. But before you separate it, you need to make it first. So salt preparation, insoluble salt, you make it by precipitation reaction. So since it is insoluble, it cannot use crystallization. So these are PbSO4 is insoluble. You can never get a saturated solution of it if it is, it's not gonna crystallize out if it's not completely soluble to begin with. So A and C are out. Now, what solution do you mix them in? You cannot use lead 2 chloride because solubility rules of chloride, AgCl and PbCl2 are white precipitate. This is to do with solubility rule of chloride ions. So B is out. All nitrates are soluble. All potassium salts are soluble. And these are soluble. So therefore, you can soluble and soluble come together to give you the precipitate, hence the precipitation reaction. Filter off the precipitate, wash the precipitate, dry the precipitate, pure dry sample of whatever you want here, which is the lead 2 sulfate here. Question 29, lithium, sodium, potassium are elements in group 1. Chlorine, bromine, iodine are elements in group 7. Which row identified the least dense? So this is to do with density. These are as stated in the syllabus: lithium, sodium, potassium. So this three will float on water, but we know that as you go down the group, the density increases down group 1. So out of the 3 metal, you want the least dense, so it's lithium. So already you can cross out C and D. But then take it and compare with Cl2, Br2 and I2. These are how they exist as elements, diatomic molecules. We know that this is a gas, this is a liquid, and this is a solid at room temperature and pressure that is at 25 degrees Celsius. So your volume decreases, but your mass increases. So we know the mass, relative atomic mass, relative molecular mass increase, volume decrease, therefore more dense. Am I correct? No, less dense. Hang on, just give me a minute. Mass increase, volume decrease, volume increase as well, I think. Gas, liquid, solid, volume increase, mass increase. but one of them is going to increase so much more than the other. We know that the solid will be denser compared to the liquid, compared to the gases, so the density also increases there as well. I think I beg your pardon, the volume there actually decrease as the volume of solid is lesser than volume of liquid, lesser than volume of gas. But clearly there is a density increasing down group 7, just like density increases down group 1 also. So the least dense of these elements is going to be the chlorine. So looking at that, there will be lithium chloride there as the, no, they're not forming a compound. We're just looking for the least dense out of the elements in the two groups there. Question 30, these are aqueous solutions of compound X when a few drops. So this means not in excess. Be very careful, not in excess. This is in sodium hydroxide aqueous. You get a white precipitate. You can have calcium 2+ ions. You can be Zn2+. It can also be Al3+. In excess sodium hydroxide, this is insoluble. Both of these hydroxides will be soluble in excess aqueous sodium hydroxide. These are few drops, not in excess. Okay. Now when they say X contains only, so only would be wrong, possibly, but other substance as well. Okay, so not only that. Now when you add nitric acid, you get a gas. This gas decolorized acidified potassium manganate 7. You know that is a common oxidizing agent. Purple going to colorless. There is a test for this gas in your syllabus. The gas is sulfur dioxide. But what is the ion present? The one that reacted with the acid. The ion present is SO3, 2-. That is what you call sulfite. It is in the theory bit of the syllabus. It's not in the paper 3 practical, but it can be asked in paper 1, paper 2, as well as paper 4 qualitative analysis question. So sulfite there is your anion, not sulfate. This one is sulfate, so not true. And of course, no visible reaction occur because this aqueous barium nitrate is test for sulfate. So we have no sulfate because there is no visible reaction there. So sulfite, 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 Zn2+, Ca2+, Al3+, because we don't know since we did not add excess sodium hydroxide there. Question 31, we have dilute sulfuric acid. Dilute sulfuric acid being electrolyzed is the same as electrolysis of water because in our dilute sulfuric acid we have H+, SO4 2- from the acid, H+ and the OH- component from the aqueous component. Either of the H+ will get electrolyzed, will get preferentially discharged at the cathode. Cation go to the cathode. Cathode will be the negatively charged electrodes. Reduction at the cathode. Red cat reduction happen at the cathode. Reduction is gain of electrons. So H+ gain electrons from H2. Balancing our atoms, 2 hydrogen atoms in the diatomic molecule. So 2H+, 2 electrons there. And that will have balanced out my equations. So what next? This is at the cathode. So hydrogen produced at the cathode, not the anode. And the oxygen will be produced at the anode because you will get OH- going to form O2. You originally already have water. This is just to balance the equation. Water is not your product. Oxygen is your product. We will have lost electrons. We've got to balance our equation. So there's 2 of that. There's 4 of that. -1 times 4. -4 on the left. -4 on the right by having 4 electrons. Having done that, so you have removed the OH- as well as the H+, so I can remove either one of it, doesn't matter. So what is left behind? So left behind H2SO4, but lesser water. So water is your solvent, lesser water would mean more concentrated of the sulfuric acid, and therefore what you can say is the concentration is going to increase for the acid. Question 32, what gases are used in light bulb? You want the unreactive gases, unreactive monatomic noble gases. So really, we don't use oxygen, as oxygen can support combustion, and when it's hot, that can react with your filaments, which are metals and stuff. So argon and neon, 1 and 3 only. Question 33, this is about rate of reaction. So first of all, what do we have? We have a solid reacting with hydrochloric acid, getting a gas. This solid could be a carbonate, it could be a metal, we don't know. The solid is in excess, that's what we know. If the solid is in excess, so that means therefore the acid HCl is limiting. That means the acid is completely used up. P and Q are the volume of gas produced under different conditions. What changes in condition produce graph P and Q if all conditions are kept the same? So P uses catalyst, Q has a lower temperature. Okay. P uses catalyst. So compared to the first experiment, P would have used a catalyst because P is faster. So if I compare the original one, let me use green color for the original, the first experiment. So this is the first experiment. So this one is steeper. So this one is going to be faster reaction. And you use a catalyst, so that one is fine. If I compare Q, Q is lower temperature. So this one is slower than the first experiment. So lower temperature will be slower. Whereas P uses a catalyst that will be faster. So A is fine. But Q also produce lesser volume of gas. So Q must have used lesser mole of the acid. But let's see B. P uses 25 cNq of more concentrated acid. More concentrated acid. So same volume, but more concentrated acid. Your acid is limiting. They cannot give you the same volume of gas. So cannot be because would be more volume of gas. Would form more gases. That means bigger volume because acid is limiting. So your graph still comes to the same volume above. So P cannot be using more concentrated acid. So that is already wrong. P uses a higher temperature. So yes, that is faster. Q uses 25 cN³ of more dilute acid. 25 cN³ of more dilute acid. So P uses higher temperature. So yes. Okay. And then Q uses 25 cN³ of more dilute acid. Your acid is limiting. P uses a higher temperature compared to the first experiment. Q uses 25 cN³ of more dilute acid. Alright, okay, I think A is wrong. A is wrong. A is wrong. A is wrong because all other conditions are kept the same. If I change temperature, but the concentration doesn't change, I should get the same volume. And my initial rate is different. That could explain the temperature. Oh, this is tricky. So maybe not A. Maybe C, because if you say Q, same volume of the acid, but more dilute. Since acid is limiting, if I decrease the concentration of the acid, then it will be slower. It's slower than the first one. It's also giving me lesser volume than the first one. So that is entirely logical as well. P uses smaller pieces. So P has greater surface area. And if that is greater surface area, so that will mean faster rate. So that one is fine. But Q uses larger pieces of solid, so it will be slower. But no change to acid because all other condition is the same. If there is no change to acid, so should be no change to the volume. But if you see the Q, it gives you much lesser volume than the first experiment, so cannot be. So D is out. So between A and C, I would definitely go for C, I think, because if A is say all other conditions are kept the same, so that means concentration and the volume should be the same. So you cannot get these if concentration and the volume of the hydrochloric acid is the same because of this. So must get different volume of gas, and that is to do with the acid being limiting since the solid is in excess. So I think C must be the only correct answer there. Question 34, which statement is correct? So a mixture of liquids boiling point differ by 35 degrees Celsius, so we say different boiling point. You can separate it by distillation. Yes, I think A is correct already. Locating agents are needed to identify colors present in ink. Not really. You use it for colorless spot or very light color. Example, amino acids, they tend to be colorless, so you need a locating agent to spray onto them so that to make them colored. Desalination of seawater, this is basically to remove salt to get drinking water, to get H2O from the seawater to produce your drinking water, pure water. You don't need fractional, what you need is simple, because you only separate an HCl, you only separate the water from the other component from the seawater. So RF value is the other way around, because it's the distance moved by the solute divided by the distance moved by the solvent. So D is wrong, C is wrong, B is wrong, only A is the answer there. Question 35, we have this particular symbol here. So we know this number at the bottom is basically your protons or your atomic number. This number on top is basically your mass or your nucleon number, and that is to do with the number of protons plus the number of neutrons, such that when you take the difference between the top number, which is bigger, and the number at the bottom, which is slightly smaller, will give you the number of neutrons. What about an atom of element X? 6 electrons. It's an atom, so it's uncharged, so the number of protons equal to number of electrons, so 1 is correct. It has 8 protons, that is wrong. It has 6 protons if you see the atomic number, which tells you the proton number to begin with. So 2 is wrong, 2 is wrong, 2 is wrong, 1 is correct. No need to check already by elimination. Of course, you can also check if you want to. Isotope of carbon. We know about relative atomic mass. This is defined in year 9. Defined relative atomic mass. Average mass of all the isotopes of an element. And this is relative to 1 over 12. 1 over 12 or 1/12 of the mass of one atom of carbon 12. And the relative atomic mass given in the periodic table for carbon is 12. You have a lot of these. This is carbon 14. This is carbon 12. So carbon 14 is an isotope of carbon 12. Well, it's an isotope of carbon because, you know, they are both 6 proton numbers, as you could get from the periodic table. So 3 is definitely correct. It's an isotope of nitrogen. Nope, because nitrogen has 7 protons. Plain simple like that. Question 36. This is about reactivity of metals. So what is the order of reactivity of the metals? So no reaction with water, whereas this is the vigorous. So this one, R is the most reactive. Just from that first column, R is the most reactive. P is the least reactive. So we can say least reactive must be P. R is the most reactive. So C and D are out. Now reaction with water, we can see slow and very slow. So the slow is going to be faster than very slow. So Q is more reactive than S. Q is more reactive than S. But do double check with the hydrochloric acid. This is no reaction, so obviously it's the least reactive again. So P again is the least reactive. So they haven't asked you on the carbon, but this is basically the last column there is useful for the positioning. So if you have carbon, now what is above carbon? So if I say more reactive than carbon, if they are more reactive than carbon, there will be no reaction. So Q and R will be more reactive than carbon. I cannot get Q and R by using carbon to reduce the metal oxide because Q and R are more reactive than carbon. So P and S are less reactive than carbon. Okay, so that is just to do with reactivity series. I wonder, let's see, I might be tricked here. Q and R is the most reactive, that's why I could reduce, hang on, Q and R cannot get it because they are more reactive than carbon. That is strange. Reaction with water, no reaction. Okay. Now why is there no reaction but you can reduce it? So I think we can say P is going to be the least reactive. So P is going to be the least reactive is definitely correct. I am happy with that. The most reactive is going to be R, but we don't know. Oh, okay, yeah, I think I get it, yeah. Answer must be A because P and S are the least reactive, but P is less reactive than S because no reaction with water, no reaction with acid. Okay, so I think P is least reactive than S. That one should already establish the answer pretty clearly there. Question 37, we have ammonia dissolving in water. This is basically NH3 is a weak base because we are showing that it dissociates partially in water. And what does it give you? To give hydroxide ions. And that is why it is a weak base. It dissociates partially in solution in water to give you OH minus, partial dissociation represented by reversible sign. Ammonia is an alkali because it produces hydroxide ion. That is correct because this will give you pH greater than 7. And it's not 7, it's greater than 7 for an alkaline solution. Adding hydroxide at equilibrium produce more ammonia. Okay, so the change is adding hydroxide. So that means concentration of hydroxide is going to go up. Equilibrium tries to decrease the concentration of hydroxide. So what is going to happen is equilibrium will try to decrease concentration of hydroxide. Your hydroxide is on the right hand side, therefore react more hydroxide. How do you react more hydroxide? You're going to shift the equilibrium to the left. So equilibrium shift to the left, you will favor backward reaction. And if you favor backward reaction, you will produce more ammonia. The yield of ammonia will increase. So 1 and 3 is definitely correct. And as you know also, NH4 plus test for ammonium ion is by adding some sodium hydroxide or any hydroxide, and then you heat it up, and then you get this gas that you tested with damp or moist red litmus paper, which will turn blue. The gas is ammonia. The ion present is ammonium ion. And a lot of fertilizers contain ammonium salt, and therefore you do not just add calcium hydroxide or calcium oxide, any base from the basic oxide, calcium oxide, or calcium hydroxide, OH minus, that will react with the ammonium salt in the fertilizer, ammonium ion in the fertilizer, and that will result in the loss of nitrogen, which is one of the nutrients needed for your agricultural crops to grow pretty well. Question 38. We have household substances. We are testing it with litmus and also methyl orange. These are the indicators stated in the syllabus under acid, bases, and salt. Which statement is correct? So lemonade, milk, and bicarbonate of soda. Bicarbonate of soda, milk, and also lemonade. Now, they are all acidic. So acid will turn the blue litmus paper going to red. But what do we see? This one turns blue. So this one is not. So that means when it turns blue, that means it should be basic or alkaline, not acidic. So A is wrong. Milk of magnesia can neutralize washing powder. What do we know about washing powder? Washing powder is blue litmus, as in the color of litmus turns blue. So washing powder is going to be alkali. And then milk of magnesia is also blue, so this is also alkali. So alkali doesn't neutralize alkali, so that one is wrong. Milk of magnesia, washing powder, and vinegar. I can tell you this is wrong because vinegar is basically, it has ethanoic acid. Ethanoic acid, as you know, from not from organic, but from weak acid under acid, bases, and salt topic. This is CH3, CH2, CH3CO2H, reversibly giving you CH3CO2 minus. This is a weak acid, partially dissociate in water to give you H plus ion. And that one says bases, that is nonsense because this one it turns red, so that one means that it's acidic. So only D must be correct. Vinegar can neutralize bicarbonate of soda, and you must have done this in the kitchen as well when you have got sodium bicarbonate or baking soda. So this is basically baking soda, and then you add some vinegar and you will produce a lot of bubbles because that is basically carbonate plus your acid giving you carbon dioxide, salt, and also water. You can also see it from here. The vinegar is acidic, the bicarbonate of soda is basic, acid and base neutralization there. Question 38, selenium is in group 6, it's just below oxygen and sulfur. Gallium is in group 3. What prediction can be made? So you can say gallium is metal, selenium is your non-metal. So a gallium atom has 3 more protons than a selenium atom. So when you see the periodic table, then you have gallium, and then they're in the same period. So this is the same period. So in the same shell, yeah, by the way. So gallium and selenium in the same period. A gallium atom has 3 more protons. That is wrong because across a period, proton number increases in the same period. There is 3 lesser protons. Gallium is more likely to form negative ions than selenium. That is also wrong. It's more likely to form positive ions because when you go across a period, it's becoming more metallic, then they have higher tendency to form negative ions. Now left between C and D, selenium atom has fewer mean lesser. So selenium atom has lesser valence electrons. That is wrong. So gallium is group 3. So number of valence electrons will be 3, and then selenium is group 6. It will have 6 valence electrons. So knowing the English word fewer means lesser, so that is wrong. And that means D must be the correct answer because as we go from left to right, group 1, group 2, we have metals which have metallic character. And as you move to the non-metals on the right hand side, so selenium has more non-metallic character than gallium there. Question 39, which statement about some metals and their compound is correct? Calcium reacts with cold water, but not with steam. That is wrong. Steam actually has more energy than cold water. Then you will have things like magnesium. Magnesium metal doesn't react with cold water, but it reacts with steam. So if you react with cold water, you must react with steam based on reactivity alone. So that is not correct. Next one is on carbonate decomposition. So this is one of the trickiest thing of all. If you think about the posocarmazil, so zinc, iron, and lead, ZiL, and then you got hydrogen, and then copper, silver, gold, etc., etc. Not to worry too much about those because we are just interested in the lead as well as the zinc. So we know that these are the most reactive metals. But we also know that from observations that K2CO3 and Na2CO3 is resistant to heat. So very difficult to decompose. So that means the more reactive you are as a metal, the more difficult it is to decompose the metal carbonate. We are not talking about the reactivity of the metal. We are simply using the reactivity of the metal to relate and to get the trend in the difficulty to decompose the metal carbonate. Potassium and sodium carbonate are very difficult to decompose as they are more reactive. Zinc is more reactive than iron, than lead. Therefore, zinc carbonate is going to be more stable. It's going to be more difficult to decompose. So lead carbonate is it's going to be less stable to heat. So lead carbonate is going to be easier to decompose than zinc carbonate. This should be lower temperature. So again, that is wrong. Magnesium can be extracted from its oxide by heating with carbon. That is not true because carbon lies in between aluminium and zinc. So we cannot already use carbon to get aluminium from aluminium oxide. We need electrolysis in order to get those metals from their respective compounds. And so yeah, not magnesium. Pure aluminium reacts with cold dilute hydrochloric acid. It can't, but you need to you have the layers of Al2O3. This is protective layer. So of course, this protective layer prevents the aluminium, the reactive surface underneath, from reacting with the hydrochloric acid directly. But it is also amphoteric oxide, and amphoteric oxide can also react with acid and bases. Until that fully reacts and the aluminium get exposed, then it will start to show its reactivity there. Question 40, the last question in this 40 question multiple choice paper 1. Greatest mass of solute. I think the easiest thing is because these are solutions with solution chemistry, n equal to C times V. This is mole. This is concentration in mole per dm cube, whereas the V must be in dm cube. So if I find the mole, and then I can work out the mass by relating mole equal to mass over mr. So the mass is going to be mole times mr, but then I also have mole equal to concentration times volume. So what I can do is the mass can be related to C times V times mr. So this must be in mole per dm cube. This must be in dm cube. And this must be in gram per mole in order to give me the mass in gram there. Okay, so hopefully that makes sense in terms of the mathematics and the units. So I'm going to, very quickly go through this thing here. If I find out the MR of NaOH, that is just going to be 23 plus 16 plus 1. That is, 23 plus 16 plus 1, that's 40. So my mass of my NaOH is going to be, my mole per dm cube is 1.00. My volume in dm cube is 100 divided by 1000. So I can do 100 times minus 3. This is standard form. 100 divided by 1000 is the same as 100 times 10 to the minus 3. On your calculator, you press 100 EXP. EXP button is the button next to the answer button on the calculator. And then straight away press minus 3. Multiply by 40, as this is n equal to C times V. And then n times mr. After I rearrange this equation, will tell me the mass. And there is the mass of the solute according to the question. And I get 4. I get 4 gram. For B, so my mass, I should probably do my MR first. My MR of H2SO4, 2 times 1 plus 32 times 1 plus 16 times 4, I get 98. And what is my mass of H2SO4 in the volume? So 0.05 mole per dm cube. Multiply by the volume, convert cm cube to dm cube. So that's 500 times 10 to the minus 3. Multiply by my MR, which is in gram per mole, which I calculated previously. So multiple choice questions, gotta think about strategy, and then gotta think about doing it very, very quickly. The third one is potassium hydroxide, KOH. So there's 39 plus 16 plus 1, there's 56. What is the mass of the KOH? Well, I have my concentration, 0.10. This is already in dm cube, so 0.1 times 1.00. And then times 56, so that is going to give me 5, am I correct? 0.1 times 56, so there's 5.6 gram there. Hang on, is that correct? 0.1 times 1 times 56, yep, so there's 5.6 gram there. Looks like that is the highest value so far. And then next one I have HCl. So that is 1 plus 35.5. That's give me 36.5. So the mass of the HCl there is just 0.01 multiplied by 2 dm cube there. 0.01 multiplied by 2 dm cube multiplied by 36.5. And I get 0.73 gram. They want the biggest mass in the solute. I think 5.6 is bigger than 4, bigger than 2.45, bigger than 0.73. So C is going to be my best answer there. And that's it really for this end of year paper 1 multiple choice questions covering all the topics in the 14 to 16 years old GCSE, IGCSE, or the all-level chemistry content for the triple sciences, pure chemistry, except for environmental chemistry as well as organic chemistry. And so that's all. Thank you for watching. Don't forget to click the button on the bottom right to subscribe to my channel. Do follow me at ptet.chemistry. That's at ptet.chemistry on Instagram, Facebook, Twitter, and Telegram to get connected. I'll see you in the next tutorial video.